Hello, ladies and gentlemen. This will be a video that covers the laws of exponents. There are 5 laws of exponents that we will cover, and there are a couple of bonus ones that I'll post later. Um, just as a review, with exponential notation, we have a base with an exponent. And our goal is going to be to write a distinct base with one whole number that has no negative exponents. So the example across the bottom is kind of where we're going. We're going to address the laws of exponents, how they work, what the rule is, give you some examples, one example or two possibly with solutions, give you some extra examples to try, and then the solutions to those. I think you will find that using the laws of exponents makes it easier to simplify some of the expressions that we've already looked at so far. So this is really going to be helpful. All right, so first let's look at this. If I have x squared times x to the 4th, then that means I'm going to have 3 x's times 4 more x's. So that will give me x to the 3 plus 4, or x to the 7th. That leads us to our first rule, which is called the product rule. So when I have two bases that are the same, as shown here, both of the bases here are a, and they are being multiplied together, then I will add those exponents together. So the product rule says that you add the exponents whenever you have the same basis. Remember this. Look back at this. This was very clear to you, I'm sure. So this is not harder. This makes that easier. So I suggest that sometimes you actually build this as you get used to some of these rules. So in particular, for the product rule, you could just go ahead and write this out. So here's an example on the handout that I gave you in class that went into your notes. The product rule shows here if I have bases of x, x to the a times x to the b is equal to x to the a plus b. And here are a couple examples over here on this side that you should have included in your notes. Stop the video if you need to jot those down. All right, so here's an example using the first rule. So we have x squared times 3 times x to the 9th times y to the 0. This actually is going to go away, and we're going to talk a little bit about why that goes away in a minute. But this is kind of a magical number. Y to the 0 is actually 1. So to use our product rule, however, we notice we have x's that are the same base. So we simply add the 2 and the 9 together. And then we multiply that by 3, and then multiply that by 1. Again, we'll come back to this idea right here. This is one of our special rules. So this will simplify to x to the 11th. So 3 times x to the 11th. All right, here's some examples to try. So go ahead and jot these down and try them. Stop the video and then come back. Don't go on. You need to try them. So quick try them and then go on and check the solutions. All of the solutions are shown on the next slide. So if you click after you get number 1 done, then you'll be able to see the answers for 2 and 3. So that won't be helpful. All right, so hopefully you're finished with these. This first one is relatively simple. A single x is really x to the 1st. So we have x to the 1 plus 5, and that gives us x to the 6th for number 1. For number 2, we're going to gather up the values, the numbers, so the 2 times 3. So we gather the 2 times 3 together and multiply those. And then we have 2 occurrences of x values. So x to the 3rd and x to the 2nd. I'll add those together. Z to the 0, remember that's 1. We've been through that before. So that falls away. So this turns into 6 times x to the 5th. Then this last one, don't let these parentheses fool you. This is just a simple string all the way through. If we had exponents that were sitting outside, then that would change these a lot. But in this case, all of these values are simply multiplied by one another. So that means we can take out the negative 9 and the 4, put those in the front and multiply the integers. Then combining the two x's, we'll have x raised to the 3 plus 2, and combining the y values, it will be y to the 5 plus 4. So our final answer on this one is negative 36, y to the 5th, y to the 9th. All right, so here's another rule. So we finished with the product rule. So now we're ready for a new one. So if we look at this one, this shows us x to the 3rd all raised to the 5th. So that means we're going to have x to the 3rd 5 times. So we have 3x's, 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 3x's. So if we're going to have 3x's 5 times, then we take 3 times 5, and we get x to the 15th. If you wanted to take the time to write out 3x's beneath each of these and count them up, you would find that you had 15 x's. So when we're dealing with the power rule, if we have a base that's raised to an exponent that's raised to another exponent, then we simply multiply those exponents together. So on your handout that's in your notes, the power rule should be written as the value of x to the a power raised to the b power as x to the a times b. And as before, we have another couple of examples over here. So stop the video if you need to write those down. So now let's go ahead and try another example for the second rule. So this is the power rule. So in this case, we have 2 times s. This is actually s to the first. So there's an exponent of 1 on this s. Then s squared raised to the 6th power, t cubed raised to the 3rd power, and 4 times t squared. So we have lots of things to keep track of here. So we've got our 2s, then we take s raised to the 2 times 6, and then t raised to the 3 times 3. Then we bring our 4t squared down. Now we're going to go back and use the product rule again, because after we have done this multiplication and we have s to the 12th and t to the 9th, we have s to the 12th, we've got s to the 1 and s to the 12th. Then we have t to the 9th and t to the 2nd. So that means we will use the product rules that says that we add those exponents together. So if we gather the 2 and the 4, then the s with its exponents added and the t with its exponents added, then we find we have a final answer of 8 times s raised to the 13th, t raised to the 11th. All right, here's some examples. So go ahead and jot these down, try these, and then come back and look at the examples in a moment. All right, so the first one, y squared raised all to the 4th power means that we'll have y to the 2 times 4 or y to the 8. This one is a to the 4th power raised to the 2nd power, so a to the 4 times 2, and a to the 3rd power raised to the 5th power, so we have 4 times 2, 3 times 5. Oh, this is a mistake. This should not be 8. This should be 15. So we should have a to the 8th times a to the 15th. So this should be a to the 8 plus 15. So this should be a to the 23rd. So this should be a to the 23rd. This is an error right here. Sorry about that. All right, in this next line, we again have multiple x's, and we have a power raised to a power and a power raised to a power. So that's the first thing that we take care of. So we've just pulled the x over, and then we've applied the power rule to say y to the 5 times 2. Then we just brought the x squared term over, and then we applied the power rule so that we have x to the 2 times 6, and then we brought the y over. So when we perform those multiplications, we end up with a y raised to the 10th and an x raised to the 12th. And then we use the product rule to combine the x values and the y values. So here are all the x values listed together here. We'll add these exponents. Here are the y values, and we'll add those exponents. So this ends up being x to the 17th, y to the 11th. All right, now our third rule is the quotient rule. Pardon me. And if we look at this one, x raised to the 10th over x to the 6th, if we expand that and then cancel the x's that appear in the numerator and the denominator, then we end up with only 4 x's in the numerator. So it's x to the 4th, but we could also look at it as though we did 10x on the top minus the 6x on the bottom. So that's our pattern, that we subtract the exponents in the quotient rule. So the quotient rule says that a to the m over a to the n is equal to a to the m minus n. And on your handout in your notes, you're going to record the quotient rule as x to the a minus b. All right, here's an example. So as we look at this one, we're going to go ahead and bring all of these values. One of the ways to think about it is that we bring the values into the numerator. So we're going to put the 2 over the 6, and then this is like 6 minus 2, and then y minus 3. So we simplify 2 over 6 to 1/3, and then we have 1/3 x to the 4th y to the negative 2. We need to, we don't want any negative exponents in our answer, so we're going to have to go ahead and manage this piece by putting the y squared in the denominator. And so our final answer becomes y to the 4th over 3 times y squared. All right, go ahead and try these. There's a few of these to try. So you're practicing the quotient rule on these. So jot these down and run through them, and then come back and check the solutions. All right, so in our first one, we have a's that appear in the numerator and the denominator. And we have an implied coefficient of 1 in the numerator. So we gather the constants, and we have 1 over 5. Then to combine the a's, we take a to the 6 minus 3, and then just the b. There's no other b to combine that with. So this one turns into 1/5 a cubed b. Another way to write this would be a cubed b all over 5. Then on the next one, first thing that we do is manage the constants, so 12 over 4. Then we combine the x terms by taking x to the 6 minus 1. And then we recognize that we have y to the negative 12. There is not anything to subtract from in the top, though. But remember, whenever we bring something out of the denominator into the numerator, then we have to change the sign to negative at that point. 12 over 4 is 3. 6 minus 1 is 5. And we have y to the 12th. So this answer becomes 3x to the 5th over y to the 12th. Then the one on the bottom, we bring the constants together, 14 over 4. We combine the x terms by subtracting 9 minus 3 on the x exponent. Then for the y exponent, it's going to be 3 minus 1, since this is implied an implied y to the 1st. Simplifying, we get 7 over 2, x to the 6th, y to the 2nd. And then rewriting it, we drive the 2 to the denominator, and our final answer is here in red. All right, so that was our third rule, the quotient rule. The fourth rule is the negative exponent rule, and we've done this one quite a bit. You've seen this one before. So we always want to the negative exponent indicates that you need to move that term to the other part of the fraction. So if it's in the numerator, it needs to go to the denominator. If it's in the denominator, it needs to go to the numerator. So we spent less time on this pattern, but it's just as valid. All right, so here's the negative exponent rule that is on your handout. Go ahead and make sure that that's written correctly in your notes. Then let's try this example. So we have 4a to the negative 10, b to the third, times 5a to the fourth. So we're going to combine a couple of exponents and also drive them to the denominator. So let's go ahead and take 4 times 5. Then we'll go ahead and add these together first, since we need to combine those exponents and they're being multiplied. So we're actually applying the product rule here. And then b to the third remains unchanged, so we leave the b to the third out here. So combining these, we get 20 in the front. We get a to the negative sixth b cubed. Since we don't want to have any negative exponents, then we want to put this a to the negative sixth in the denominator. So our final answer becomes 20b cubed over a to the sixth power. All right. Go ahead and let's look at this one. This is another bit of an example. If we want to look at this one, this shows that we're going to drive the y into the denominator. So when we do that, then we drive the x to the negative 3 into the numerator. So this is a very interesting problem because it shows you, it highlights how you need to flip this term and flip this term to the other parts of the fraction. So now this one becomes very easy to solve. It's going to be x to the 2 plus 3. So and then we're going to have we have a common factor of 4 between 12 and 8. So we'll end up with 3 times x to the 5th over 2y. Okay, go ahead and practice these, jot these down, stop the video, give these a whirl, and then come back and see how you did. All right, 8 raised to the negative 3 means that we're going to have 1 over 8 cubed, and that's the same thing as 1 over 512. On number 2, we have a negative exponent in the denominator, so that means we're going to bring it into the numerator. And I have a typo here. This should be a negative 5. So, let me go back. So this should be x squared minus negative 5. I apologize. And then the y remains in the denominator with the 4. But this should be 2 minus negative 5. So that's like 2 plus 5. So this should be x to the 7th. So this should be 3x to the 7th over 2y cubed. All right, then on number 3, we have an x that goes into the denominator because of this negative sign, and this other term will go into the denominator because of that negative sign. So we can go ahead and combine them. However, we can use the power rule to combine them. So that's what I did here. I went ahead and added them. So negative 3 plus negative 4 is going to give me x to the negative 7. Then that drives the x to the 7th into the denominator. So hopefully that pattern makes sense. Then on this last one, we have the whole expression raised to the negative 2. So the whole expression, everything inside of the parentheses needs to go into the denominator, and then our negative 2 flips to a positive 2 now in the denominator. Now, since this whole expression is squared, then you have to square every term here. So that means that we're going to have 2 squared times a to the 3 times 2 and b squared. So simplifying that becomes 1 over 4 a to the 6th b squared. All right, so this is going to be how we talk about our last rule, which was mentioned a little bit earlier. um, the zero exponent rule. So if we look at a problem like this, x cubed over x cubed, and if we want to simplify this when x is equal to 2, then if you put 2 in both places, then we find we have 8 over 8, which is 1. If we use the quotient rule, then what we find is that we can say that we take 3 minus 3, so we did x to the 3 minus 3, and we got x to the 0. So since these expressions that we started with were the same, then it's logical to say that x to the 0 equals 1. So that's our rule. So your zero exponent rule is that a to the 0 is equal to 1. All right, here's an example that already is worked out. So if you have 15x all raised to the 0, then this term is eliminated altogether, and that just becomes 1. So that 1 is represented right here. Then I have I'm going to apply the quotient rule. So I'm going to take y to the 5th over y squared, and I'll end up with y5 minus 2, and then x to the 1 minus 3 when I combine the x values. So that gives me 1/5 y cubed x to the negative 2, and my final answer is y cubed over 5x squared. All right, practice these. Remember, when you raise a value to the 0 power, then that is 1. So anything raised to the 0 power is 1. Try these real quick and then come back and check your answer. Okay, so in this case, the 0 power applies to what's in the parentheses only. So this expression all goes to 0, and we're left with a 4. So number 1 is simply 4. On number 2, everything in the denominator is raised to the 0 power. So we end up with the numerator over 1. So we apply the exponent rule here, multiply those exponents, and get a final answer of x to the 6th. Then on the last one, even though we have a lot of information inside of these outside parentheses, the 7a to the negative 5th, that is all raised to the 0 power, so this is simply 1. All right, ladies and gentlemen, thank you for making your way through that. I know it was long. If after you try these and practice them and get the hang of them, they get much easier, and they're just little puzzles. So I think you'll find that they go well if you just do a little practice.